I'm going to run through these relatively quickly. We did them in class, but this way if you miss class, you'll have the same opportunity to turn it in. And again, you'll have to show work. This one we talked about in class, how to do it with your calculator. First thing you do if you're doing it by hand is the cube root of any negative is going to be a negative number. And then we recognize, hopefully, that 8 can be factored as 2 times 2 times 2, so it's a perfect cube root. So the cube root of 8 is 2, and the negative out front makes it negative 2. Next one evaluates. Let's find out what it's equal to. You could try it in your calculator. I think it's easier to recognize. Oops, that's a negative 64. I think it's quicker to recognize this is really just the cube root of negative 64. Again, we can take the negative out right away. And we have to cube root the 64 here. But 64 is 4 times 4 times 4. It's a perfect fourth root. So you just get negative 4. Problem number 7, you're going to have to do that one with your calculator. You could maybe approximate it by hand, but without a calculator, you'd have to do an approximation for what the cube root of 23 is. Then you'd have to raise it to the negative 2 power, which means put it in the denominator. So there it is, kind of simplified and broken down, but since we don't know what the cube root of 23 is, we just have to approximate it. Oops, that should be a 2 right there. But so let's do it with our calculators. In this case, just be careful when you enter your calculator. If you use the X to the Y button or Y to the X button, you want to make sure you put that exponent in parentheses. And if you do it correctly, you should get answer B here. Number 5, same deal. Use your calculator. On our phone calculators, you'd have to enter it this way, 3, 2, 2, 4. Then you'd have to press the button that looked like this, I believe, on your phones. Then you have to enter the number 5 for the fifth root, and then finally you enter the equal sign. Your calculators may do it differently. Regardless, you should get answer A here. It really doesn't make sense that the fifth root would be 1. It certainly can't be bigger than what you're taking the fifth root of. Okay, so maybe it could be this one, but you have to take 100 times itself 5 times, and that's going to be more than 13,000. So you could narrow it down to 6.67 pretty quick. Here we have a solved problem. Notice the x is underneath, or it's trapped underneath this exponent here. We want to get to that x, so we are going to undo both sides. Now in this case, our term with the x in it was already isolated, so we didn't have to add or subtract anything. So we, on the left-hand side, just get x minus 3, the fifth root of something to the fifth power. They just cancel each other out. And over here, we have the fifth root 324. And so we get out our calculator, and we know to use our calculator because look at these answers here. They're decimals. They have changed this to a decimal value. They found out what it was. And when you type it into your calculator, you should get 3.18 out for a number. Now, we aren't quite done here because this is x minus 3 is 3.18. So we do have to get the x alone so we know what it equals. So we'll just add 3 to both sides. And that will tell us x is 6.18 right there. Oops. On this next problem, if you're good with your calculator, you could get the right answer. But but you'd have to be very careful. Instead, what we want to use is one of our properties for exponents that we learned, which is a to the m over a to the n. When your bases are the same, both a's, ours are both 8s. To simplify the expression, the law says just keep that base, and it's to the m minus n power. So we just follow that rule. We keep our base, and then it's to the m, that's the numerator's exponent, minus n, the denominator's exponent. And that's just subtract two fractions. I've got 5/3 and I take away 2/3, so that leaves me with 3/3, which is really 8 to the 1, which is just 8. So there we go, answer B. This is a multiplication. We can tell it's got that dot right there, so we're multiplying. The rule for multiplying with radicals, as long as they're both the same index, these are both cube roots, then you can multiply them. And we just multiply the outside stuff, let's highlight that, times the outside stuff, so we have to do a 1 times 4, which is just 4. Then the inside stuff times the inside stuff, so the 6 is under it and the 18's under it, so we just multiply those together, and that is 108. You'd be tempted at this point to choose answer A, but you can't because our directions up here are to simplify. Get that in screen for you there. Because our directions say simplify, it doesn't mean just multiply them, it means simplify it to the simplest answer. And 108, you can actually cube root some of it. Let's look at the factors of 108. So this is where we just kind of run off to the side of our paper and we start making that factor tree. So there's the 108. Let's see, the first factorization, you could use 2 and 54 if you want to. However, I'm going to use 6 and 18. And I knew that because, remember, 6 times 18 gave me the 108. So I already know how it factors partially. And I just keep going. 6 is 2 times 3. 18 is 2 times 9. So I'm just bringing these down. And 9 is 3 times 3. So there it is factored. And remember, when we're doing cube roots, what we do is we look for 3 of a kind. We've got 3 3's that can come out as a single 3. So when you bring it outside, you multiply it with the 4. So 3 times 4 is 12. Cube root, and what's left inside? This 2 and this 2. So 2 times 2, 4. There is our simplest radical form. Problem 12 here. We would try to simplify 9/5, but 9/5, they're relatively prime to each other, so we can't do that. So then we separate them, like so, and we individually square root them. Square root of 9 is 3, of course, and square root of 5 we can't do. And see, this is answer A, but you'd be incorrect to choose A. Because while these are, obviously equivalent, neither one of these is in simplest radical form. In simplest radical form, not only can you have to take everything out from underneath the radical that you can, but you also can never have a radical in the denominator. So we have to rationalize it. How do we rationalize it? We multiply by something to make it a perfect square. In this case, by root 5. On the top, we're going to get 3 root 5. But in the denominator, root 5 times root 5, that's root 25, or just 5. That is our simplest radical form, B. Another problem where we have a radical in the denominator. This one we should recognize from our homework. You have to multiply this radical binomial expression times its conjugate. The conjugate, remember, is exactly the same as that denominator, except you change the sign right between the two numbers. If this is positive, multiply by a negative between them. If this was negative, multiply by the 2 and the root 5 with a positive between them. Now we just have to do the multiplications, and if we do those correct, you'll automatically get the correct answer. So we distribute. Now that 4 is on the outside, so when you take it times the root 5, it stays on the outside. So the numerator is a pretty easy multiplication. All right, let's distribute the 2. 2 times 2. Distribute the 2. Now it gets multiplied by the 1 out in front, so, or the negative 1, so that's negative 2. And then times the root 5. Then we go root 5 times 2, so that's positive 2 root 5. And lastly, positive times negative, root 5 times root 5 is root 25. Let's make this fraction bar longer. Now that looks like a big mess, but it's not. Our numerator here is all simplified. Our denominator, though, we've got what we are hoping would happen. The root 5s here have canceled each other out. The 4 is just a 4, but this minus sign is minus what? The square root of 25, which is 5. So it's just 4 minus 5 down there, or negative 1. Now you'll notice, if I pull the answer sheet over here, we don't have any answers that are 8 minus 4 root 5 over negative 1. So what they've done, or what you can do, is divide everybody in the numerator by negative 1. And so it becomes negative 8 and positive 4 root 5. And that does match one of our answers. In this problem, we're adding two radicals. These are not like radicals. They have the right indexes, but you have to have the same number, the same radicand underneath. These don't. Now, they can be simplified, at least this second one can, because the cube root of 81 factors as 3 times 3 is 9, times 3 is 27, times 3 is 81. It factors as 4 3s. And so, because the index here is 3, it means take out any triplets. Well, we certainly have 3 3s right here, so we're going to take that, pull it out. That's really just the cube root of 27, which is 3. Now, when you bring that 3 out, you multiply it. So 6 times 3 is 18. And what's left inside? Just a 3. And see, now it turns out they are like radicals, so we can add them. I've got a total of 27 what? Cube roots of 3. And there we go. Looks like that's answer A. Solving a few problems. Get the factor, the term rather, with the x in it by itself. We've got to get rid of that 1/3 in this first one. So we just triple both sides. Equals 45. And then we get out our calculators and we go 4th root of the left side. It's a poor looking 4. And 4th root of the right side. So x is equal to the 4th root of 45. So we grab our calculators. I don't know. Yeah, I do know what that is. This comes out to 2.59. But because you took the 4th root of it, you have to put plus or minus. If you had 4 negative numbers multiplied together, they would give you a positive. If you have 4 positives multiplied together, you get a positive. So in this case, we got to make sure we choose the plus or minus 259. Keep this in mind. If you ever square root, 4th root, 6th root, 8th root, these are always going to be plus or minus answers. Plus or minus. Okay, it's the even ones that always give you plus or minus. Odd ones, you don't have to worry about it. It's just going to either be a positive or a negative, but not a possibility of both. Number 16, very similar problem, but this time instead of multiplying both sides by something, we have to add this 32 to the other side. Equals 82. And now we can square root both sides. This is a square root, so we do get plus or minus, and it must be 9.06. And I knew it was going to be that one as soon as I saw the square root of 82, because square root of 81 is 9. This is a little bit bigger than 9, so 9.06 sounds about right. And last one on this. Ooh, radical is already isolated. All we have to do is cube both sides. 2 cubed now is 8. We'll subtract the 1, giving us 7. So 7 over 2. Looks like our answer. Number 12, the inverse problems. We've done a bunch of these. Let's find it here. Remember, change the function notation to y. Here comes the flip-flop. So where there's an x, I put a y, and where there's a y, I put an x. I should have put those in a different color to show you that I've moved them. Now we have to solve for y, so I'm going to subtract this 4 first. I'll have x minus 4 equals 2/3 times y. I'm going to do this in stages. You could multiply by the reciprocal at this point. That'd be fine, but I like to do it in steps. I say, let's multiply both sides by 3. Distribute 3x minus 12. And on the right side, the 3's cancel. And then lastly, I do my second step, and I divide by 2. So I end up with y equals 3x minus 12 all over 2. See if we got that anywhere here. And I'm seeing it 3x minus 12 all over 2. Certainly looks like answer C. Last problem, graphing problem. Here's the question. Which function below has an inverse that is also a function? Well, we're just looking for one that passes the horizontal line test. This one flunks it. That means he doesn't have an inverse function. This next one, it has a horizontal line as part of its graph. Therefore, a horizontal line can hit it an infinite number of points. Every time it touches it, it hits it. So that one's not doesn't have an inverse function. A circle certainly doesn't have an inverse function. Heck, a circle isn't even a function to begin with because it flunks the vertical line test. So the only possible one up here is this half a parabola laying on its side. Any horizontal line only hits it in a single point, not like this. And so we're going to choose B. That takes care of your review. Now make sure you not only put down some work, but also submit the Google form and your work with it.